Alright, apologize. Technical difficulties. Alright, so I'm going to just write off to the side here. Number 1, right, we have 14a minus 35. And I said the GCF here would be 7, right? So we factor the 7 out. And when we divide it out from both terms, what do we get? We get 2a minus 5, right? So that's the final answer for number 1. Everyone okay with that? Number 2, I don't know if you could see this, it might be too small, but I'll just try to write it over here again. Alright, so in number 2, we have two terms again. The GCF, right, would be what? It would be 3m, right? So if you got that, you take 3m and you factor it out from both terms, right? The first term would give you 3m. The second term would give you minus 7. Did you all get that one? Okay, good. Number 3, two terms again. The first term has s squared t. The second term only has s squared. Therefore, t is not a part of your GCF, right? So your GCF for this one, if you look at the number part, right, what goes into both? It's not 16, but it's 8, right? So 8, and then you have your s squared. So we divide 8s squared out from both terms, all the terms, and we get 3t for the first, and then minus 2 for the second. If at any point you have a question, please ask in chat, or you could just say it out loud too. Okay. Alright, number 4. I see that 18 actually divides into 36, right? So the GCF for this one would have an 18 in it, and then the smallest a and the smallest b, right? The lowest power, the lowest exponent. So I have 18ab, and when we factor it out from the first, all we're left with is a. Now I look at the second, it's positive, so this is plus 2b. Okay? Alright, number 5. I see that there is a 9 that divides into both of these, and an s cubed. So for this one, I see GCF 9s cubed. That's the lowest exponent, right, for s. So we divide out 9, we factor out 9s cubed, and then we have what? 3s for the first term, and then plus 2 for the second term. Alright? Okay, now we have 3 terms in number 6. So I gotta find the greatest common factor for all 3 terms. So I noticed that the 3, the smallest number, right, divides into all of the numbers, the coefficients, right? So that means the GCF will have a 3. And then I see the smallest x, right, the lowest exponent is 1, so it's just 3x. We factor that out, 3x. And in the first term here, we have x squared, right? In the second term, it's a negative, so it's minus 2x. And in the third term, we have plus 5. Okay? So hopefully this is, the first 6 were pretty easy. Getting a little more difficult now. We have 3 terms, right, in number 7. And if you look at all the numerical coefficients, 18, negative 27, and 36, I see that there's let me see here, there would possibly 3, right? 9, right? 9, because 18 doesn't go into 27, so 9. GCF would be a 9, and then I see m squared, and for n, I see just n to the first, so just n. So that's your GCF. So let's factor that out. 9m squared n, and what do we get? We get 2, right? 18 divided by 9 is 2, and we have an n here. Then we have negative 27 divided by 9 is negative 3, and then the m squared n cancel out. And in the last term, we have 36 divided by 9 is plus 4. M squared cancels out, and n cubed over n is n squared. Hopefully you got that, right? Alright, number 8. So what's a number that divides into both 81 and 63? So let me start thinking here. I usually start with the smaller number, see if it divides into the other numbers, but it doesn't, right? So then I look at 63. What are the factors of 63? There's what? There's 9 times 7, right? So I see that 7 is a prime number. So I'm like, okay, so then possibly the 9 is the GCF. 9 divides into 81, right? And then I look at the x's. I see x to the 4th is the smallest x, right? And y to the 6 is in both of them. So that's how I came to figure out the GCF, all right? So let's factor that out. We got 9x to the 4th, y to the 6th. When we factor it out from the first term, 81 divided by 9 is 9. X to the 7th over x to the 4th is x to the 3rd. And then the y to the 6th cancel out. Second term, 63 divided by 9 is 7. X to the 4th cancels out, y to the 6th cancels out. So that's all we're left with, right? So you see how they're becoming more challenging, but as long as you look for the greatest common factor, right, you will always get the correct answer. So just start off with the numbers first and then the variables. So let's see, number 9, I see 8, 24, and 16, right? So I take the smallest of the three and I try to divide it into the other numbers, and if they do, that's the GCF, which it does, right? 8 goes into 24 and 16. So GCF is 8. Then I look for the smallest A and the smallest B. So it's 8AB. So let's factor out 8AB. What are we left with? The first term we just have A, right? In the second term we have plus 3, and the AB's cancel out. And then in the last term it's negative, so don't confuse the signs, right? Negative 2, and we have a B. Okay, any questions there? Alright. Number 10 was probably super challenging because we didn't see an example just like 10. We saw something like 11 and 12. So let's skip number 10 for now. We're going to actually see a bunch of problems like that. Let's move to number 11. So in number 11, we have two terms right now, and we have a common binomial factor. The common binomial factor, let me use the red here. You see how in both groups we have the 3x plus 4y, 3x plus 4y. So we factor that out, 3x plus 4y. So if we factor it out from the first group, 3x plus 4y cancels out and we just have 2x left, right? Then we move on to the second group. We have minus y times 3x plus 4y. So we factored out the 3x plus 4y. We're left with just this minus y, right? Same with number 12. We have the common binomial factor of w minus 3z in both groups, right? So we factor out as a group. Make sure you write the parentheses, otherwise you are writing it incorrectly and it becomes a different problem. Alright, so we have in our first term, we cancel out w minus 3z, we have 5. And the second term, we just have this minus w. Okay? Does anyone have questions from the homework last night? Let me just write the first one over here. Yeah. So if you want, you could even take screenshots of this. The video will be posted on YouTube, so you can just look at it there too. Okay? Alright, let's see here. Where's my... Oh, there we go. Alright. Ready for some new stuff? Okay. Today we will be talking about some special factoring problems. Uh-oh, Jonathan's lagging. Are you on Wi-Fi, Jonathan? I sound like an Android. Okay. How's your Wi-Fi signal? Is it strong? If it's not strong, can you move closer to your router? Oh yeah, that might be the issue. Um, if you can, I would move closer to your router. Yeah. Okay. That's the thing about these online courses. I've taught online courses before, and the best thing is to definitely stay close to the router or even use hardwire Cat5. Alright, so let's move on. We're going to be talking about something called the difference of squares, or in some books you might see it as difference of two squares. So here is our first property. If we have a problem, the problem here is a squared minus b squared. So you see how this is the difference of two squares, right? Difference means to subtract. And what are you subtracting? You're subtracting something squared and something else squared, right? And when that happens, the factoring, in any factoring problem with this kind of an example, you'll always get a plus b. This is always going to factor into a plus b times a minus b. Okay, so let's look at the factoring problem right below. It says x squared minus 16, right? So if you look at this, right, the first one is an x squared, right? The second one is 16 is what? 4 squared, right? So this is technically a difference of squares. Therefore, you can write this as x plus 4 times x minus 4, as you can see below. Okay, so let's try this next problem. It says factor m squared minus 49. So if you see, the 49 is actually a what? This is, if I were to write it in the same format, this is m squared minus 7 squared, right? So that means this is just m plus 7 times m minus 7 in parentheses. Any questions with that? Alright, then let's move on to another example. Okay, over here we have 4a squared minus 9. So now this, you have to realize that 4 is actually a perfect square, right? It's 2 times 2. So you would have to think of it as 2a times 2a. So that's why it's 2a in parentheses squared. And then you have your minus 9, which is 3 squared, right? Oh, shoot. Okay. So that, now you see how this is 2a minus or plus 3 and 2a minus 3. Okay, does everyone see that pattern? Okay, if you understand that, I want you to try check yourself number 2 here. Factor 9b squared minus 25. Give that a try. I'll give you a minute. And if you get it, you can, I guess, either type it out in chat. Don't say it out loud though. How we doing? see 2 people typing in chat. Okay, that is correct. All right, so that is very good. So this is technically, we know that this 9, as you can all see, 9b squared, right? This is our 3b in parentheses squared minus 5 squared, right? So this is the part that you actually don't have to write. It's just so that you can see the thought process. Just the final answer is good enough. 3b plus 5 times 3b minus 5. That is correct. Great job. Also on the computer, for those of you who don't know, that caret symbol that Nafez used after the 3b, that's how you write an exponent. Okay, in case you didn't know. If you ever need to type out a math problem on the computer, that's what you would have to do. All right. Oh no. Let me see. Okay, let's take a look at another one. Now this one is a little bit more tricky. So you see how it says factor 25a squared minus 16b to the fourth. So this isn't just b squared, it's b to the fourth, right? So when you take a look at this right here, you have to see that, okay, so let's look at the 25a squared first. So we know that 25a squared comes out to this, right? 5a in parentheses squared. And then the 16 we know is a 4. B to the fourth, right? If you split it into 2, it's actually just b squared, right? Because this is technically what? This is the power rule that we learned the previous week, right? When you have b squared, raise it to the second power, you multiply the exponents, that's why it's b to the fourth, right? So in this case, right, you can just divide by 2. Whether it's b to the fourth or if they give you a b to the sixth, you just divide by 2, all right? So that's how we came out with 4b squared as the other, the square of the other one, right? All right, so now that leads us to 5a plus 4b squared times 5a minus 4b squared. And that's all we have to do for this one. So if you take a look at, check yourself number 3, this is what? This is 49 is 7. C to the fourth would give us, if we divide by 2, it would give you 2, right? So this is our first factor squared minus 3, right? 9 is 3 squared, and then we have d. So this is what the problem would look like. So when you factor it, the difference of squares would be 7c squared plus 3d times 7c squared minus 3d. Any questions with this one? Okay. Moving on to our next one. Okay, so remember what I said when we started our factoring chapter? I said the first step of every factoring problem is to look for the GCF, right? So here's a perfect example of such a case. So you see it says factor 32x squared y minus 18y cubed. Now, this doesn't look like a difference of squares, but this is actually going to become a difference of squares problem. So let's take a look at the GCF. What divides into both 32 and 18? Can anyone tell me that? The GCF. You could say it out loud in this one. 6 is correct. 8 would not divide into the 18, right? Oh, actually, not 6. Wait, 6 is not correct. Sorry about that. 8 would not go into 18. 6 would not go into the 32, right? Well, what else would go into it? 4 would actually not divide into 18. So if you forgot, just list out the factors, right? And you'll see what the greatest common factor is. So for example, if I do the GCF of 32, right? So what's 32? I mean, not the GCF, the factors of 32. You have 1 and 32, right? You have 2 and 16, right? 3 does not work. 4 and 8, right? So those are the factors of 32. If you list out the factors of 18, you have 1 and 18, 2 and 9, and then 3 and 6, right? So the GCF is actually 2 for at least the numerical coefficients. Excuse me. Then I look at the variables. There's no x squared in the second term. The y's, the lowest one is y to the first. So the GCF is actually what? It's 2y, right? So let's factor that out. When we factor it out, we're left with 2y times, now we get 16x squared for the first term, and then we subtract because it's a negative, and then 18 divided by 2 is 9, and then y squared, right? Okay, so here's the important part. Look at this. Once you factor the GCF, don't assume you're done. I would take a look at the other factor and see if that can be factored further. So you see we just learned about the difference of squares. 16x squared minus 9y squared. That's what? A difference of squares, right? This is actually 4x in parentheses squared minus 3y in parentheses squared, right? So this is a difference of squares. So this would factor further to 4x plus 3y times 4x minus 3y. So that's what the 16x squared minus 9y squared is. And don't forget 2y is your other factor from before. So the final answer will be this. 3 factors, 2y, 4x plus 3y, and 4x minus 3y. Okay? So let's try check yourself 4. I'll give you a minute or two. Let me see here if I can. I don't think I can pause the recording, can I? No, I cannot. Oh no. Alright, do you remember when we were studying the previous chapter, we learned how to multiply binomials, right? And we actually saw this specific problem here. Let me write it out. If we have a plus b, this quantity is squared, right? If we were to do this the long way, we know that a plus b is the base, right? That means we multiply it by itself 2 times because it's squared. And we learned how to distribute, right? Foiling technique here, right? If you forgot the foiling technique, I'll quickly show you with arrows. We do the first times the first, right? And then the a times b is next, right? That's the outer. And then b times a is the inner. And then b times b, that's the last, right? So if you recall, that's our foiling technique. So the first a times a is a squared, right? Then we have a times b, right? That's our ab. And then b times a, we still write it alphabetically here, ab. And then b times b is b squared. Do you all remember this? We learned this a while back. And then we saw that the two middle terms, AB, are like terms. So AB plus AB, that would give us 2AB. Right? So this is A squared plus 2AB plus B squared. This is actually a perfect square trinomial. Right? This A squared plus 2AB plus B squared, that's a perfect square trinomial. So anytime you get a problem where you have to factor, right, A squared plus 2AB plus B squared, it's always going to factor into A plus B squared. Okay, so this might not make too much sense right now, but you're going to see shortly that these factoring problems are pretty common. Alright, so let's look at A minus B squared, right? This is, if you expand it, it's A minus B times A minus B, right? If you distribute, right, you get A times A is A squared. A times minus B is minus AB. Minus B times A is minus AB. And minus B times minus B, right? Negative B times negative B is positive B squared. Then you have your two like terms in the middle. So you have A squared minus AB is minus 2AB, and then plus B squared. Right? This is what we learned in chapter 5. So if we were to get a factoring problem where it's A squared minus 2AB plus B squared, right? This would always factor into A minus B in parentheses squared. Okay, so I know using all these variables here, it's not as easy to understand. So let's take a look at an example with some numbers, and like this one right here. So we're going to be asked to factor x squared plus 10x plus 25. So let's take a look here. We have our first term, right, is x squared, right? So that means this is probably going to be here. Let's look. We have x squared here, right? This is over here. We're x squared. Over here, it's positive 25. So that's my 5 squared, right? Then I look at the middle number here. It's plus 10x. So I want to see if this is a perfect square trinomial. The way you test it out is you take 2 times the first factor, x, times the second factor, 5, right? And if this comes out to the middle number, the middle term, that means this is a perfect square trinomial. See that? 2 times x times 5. This first number is always a 2. Because if you recall, it was 2ab from our formula, right? So this is actually a perfect square trinomial. That means this will always factor to x plus 5. The first plus the second, and then squared. Okay, so let's look at this. Check yourself here. Y squared plus 4y plus 49. So we need to check, is this a perfect square trinomial? How do we check? So I know that this first term here, this is y, right? Y squared. And this 49 is 7 squared, right? So to check, I need to see, is this 14y? Is if I do 2 times the first times the second, does it come out to the middle term? Yes, this is 14y. So this is actually a perfect square trinomial. So this will always factor, right? This is plus 14y. So this will factor to what? Y plus 7 parentheses squared. Does that make sense, everyone? Alright, let's look at some more examples. Over here we have x squared minus 6x plus 9, right? So I'm going to take a look here. So when the middle term is a minus, right? That's when we have the other one. Remember, a minus b squared, like that, right? This is our a squared minus 2ab plus b squared. So when the middle term is a minus, that means that you're going to have a minus sign in your factoring when you factor. Alright, so first term x squared is just x, right? Second term is plus 9, but because of this middle term is a minus 6x, we have to look at it as a negative 3. Okay, so this is actually negative 3 squared. So let's take a look here. Let's do our test real quick. So 2 times the first is x times the second. That comes out to what? Negative 6x, which is our middle term. Therefore, this will factor into the first, right? And then the second. Right? Or you could even look at it as just the first, if it's the second is 3 squared, right? So the first minus the second. That might be a better way to look at it. Right? So let's take a look at check yourself 8. This is the first factor is t, right? The second factor is 8 squared, right? So t squared, 8 squared. The middle term is minus 16t. So if we check, we have 2 times, so we're gonna do the minus out here this time. Minus 2 times t times 8. That's what? Negative 16t. So this is actually a perfect square trinomial. This will factor to what? T, right? And then minus the second. I'm hoping this makes sense to everyone. If you have a question, please ask in chat. All right. So now we're looking at a little bit more difficult of a problem here. So you have 9x squared plus 30xy plus 25y squared. So you're like, wow, this is a lot more difficult. Just take a look at each term, okay? When you have 3 terms, see if you can find the factors of the first and the last. So 9x squared is actually what? This is just 3x, right? 3x squared. Then I look at the 25y squared. That's just 5y in parentheses squared, right? So now the middle term is plus 30xy. So I'm going to do the test. 2 times the first times the second. What does this come out to? 2 times 3 is 6. 6 times 5 is 30. And then we have 30xy. So this is actually a perfect square trinomial. What does it factor into? It's going to factor into the first, which is 3x, plus the second, 5y, and then parentheses squared. It's not too bad, is it? Should we take a look at this one here? So just take a look at here. You see this is a minus 28, right? So the factor is going to be something minus something squared. So why don't you try this one? I'll let you take a look. So you have to find the first and the second. I'm not the second, the last term, which is the second for the factor. Oh, we're missing a lot of people today. Did you all get it? Okay, let's see here. The 4v, we know that's what? That's a 2v, right? 4v squared is 2v squared. The 49 is a 7w, right? Squared. So hopefully you got that. Then we do the test. We do 2 times the first times the second. And that's 2 times 2 is 4. 4 times 7 is 28. And then we have VW. So this does come out to the middle, right? So this is 2V minus 7W in parentheses squared. Okay. Hopefully y'all got that one. So now let's do some practice problems. Alright, first up, this is just practice of everything we've been doing so far. Actually, let's do the ones that we were just doing first. Here we go. Alright, so I'll give you some time to work on this. I'll do number 63, okay? And then you could try the rest. So we have x squared minus 4x plus 4. So I see it's 3 terms, right? Remember, difference of squares, there are only 2 terms, but this one has 3 terms. That's how I know it's not a difference of squares, right? So I see that this is 2 squared, right? 4 is 2 squared, and the x squared is just x squared, right? So I'll test it out now. I'm going to do 2 times x times 2, and that comes out to 4x, right? 4x right here with a minus sign. So that means this is going to factor into x minus, right, 2 parentheses squared, right? Okay, so please try, you could try these 6 problems here. Alright, so we know that the first one is a difference of 2 squares, right? M squared minus n squared. So we know the 2 factors. This will always factor into m plus n times m minus n in parentheses, right? So hopefully that wasn't too bad. Number 12, right? We know the first one is just r, right? R squared minus 3 squared. So hopefully you have r plus 3 times r minus 3. Did everyone get those? Yep. Okay. Number 13, a little bit harder, but hopefully not too hard. If you see a difference of squares problem, you got to know it's always going to be something squared minus something else squared, right? So if you see a number like 169, I know most of you don't have this memorized, right? But if you do happen to get at least up to like 15 squared memorized, that would be great. But if not, that's fine. We know 10 squared is 100, 11 squared 121, 12 squared 144. Most people seem to know up to 12 squared, right? 13 squared is your 169. 14 squared is your 196. So that's how I know this is 13 squared, right? So x squared minus 13 squared. That's our difference of squares. So this should be x plus 13, x minus 13. Okay, so that one's not too bad. Number 14, another easy problem here, right? This is c plus d times c minus d, right? Easy one there. Oh, forgot the parentheses, right? Did y'all finish number 15 and 16 as well? Yeah? Okay, so 49 is 7 squared. So don't mess up the order here. It's always the first and then the second, right? 7 is the first this time. So that means this is 7 plus y times 7 minus y. Okay, so hopefully you did not write it the other way around, like y plus 7, y minus 7. That would actually give you the wrong answer. Alright, so like I said earlier, 196 is actually 14 squared, right? So this one is 14 plus y, 14 minus y. Any questions with that? Alright, let's go on to the more difficult problems. It's not that difficult though, right? Everyone should be able to do these as well. So we have 9b squared minus 16. So I'll give you a few minutes to try these. Shouldn't be too bad. Okay, so our first one, we know that this is actually 3b, right? And this is minus 4 squared, right? So this is difference of squares. That means our factors are 3b plus 4 times 3b minus 4. Okay. Number 18. We know 36 is 6 squared minus x squared, difference of squares, right? So that gives us 6 plus x times 6 minus x. And number 19. So 16w squared, that's 4w in parentheses squared, minus 49 is 7 squared. So that means this is 4w plus 7 times 4w minus 7. Any questions with those? If not, I'll give you some time to work on the next three. Alright, number 20. We have 4x squared. That's what? That's 2x, right? Squared. Minus 25 is 5 squared. So that gives us 2x plus 5 times 2x minus 5. Okay, number 21. 4s squared minus 9r squared. So two terms, right? This is a subtraction. So we see that 4s is actually 2s, right? 2s and squared minus 9r squared is what? That's our 3r squared, right? See our difference of squares? So that gives us the two factors of 2s plus 3r times 2s minus 3r. Hopefully you got that one. Number 22. Number 22, 64y squared. So that gives us 8y, right? And minus x squared is just x. So that's the difference of squares. 8y plus x times 8y minus x. Alright, looking good here. A lot more to do, just these over here, and I think we're good for today. So let's take a look at, okay, these are just same problems. Let's just finish these, work together here. So 9w squared, what do we get for 9w squared? So that's 3w, right? So 3w squared minus 49z squared, that's 7z, right? So that's a difference of squares. That gives us 3w plus 7z times 3w minus 7z. Not too bad, right? Difference of squares is pretty easy once you get the hang of it. 24. That's 25x squared minus 81y squared. So two terms, and this is a subtraction problem. No GCF, right? So that means I'm going to take a look here at the 25x squared gives us 5x quantity squared minus 81 Now y squared is 9y, right? So difference of squares gives us 5x plus 9y times 5x minus 9y. Right? Not too bad. Okay, 25. What do we have here? This is subtraction problem, two terms. So this first one is 7a squared minus the second one is 3b. Square that. Difference of squares. So that's 7a plus 3b times the quantity 7a minus 3b. Right? Okay, last one here. 64m squared minus 9n squared. So subtraction, two terms. I'm immediately thinking difference of squares. Right? There's no GCF. So let's see here. 64m squared gives us 8m, right? Minus 9n squared, so that's what? 3n in parentheses squared. So this is our difference of squares. Our factors are 8m plus 3n times 8m minus 3n. Okay? I don't know if that was a little too fast for everyone, but I hope when you can review the video for this, right? It makes a lot of sense, right? You look at the two terms, it's a subtraction problem. It's the first squared minus the second squared, so that gives you, the first plus the second times the first minus the second. Okay? Okay, the last 6 problems for today. What do we have here? So this looks like more difference of squares questions, right? So let's see here. I see x squared, y squared. This is two variables here, right? But if you think about it, this is still just an xy squared, right? In parentheses, xy squared minus 4 squared. So this is a regular difference of squares question. The only thing is they're two variables, right? So that means it's the first plus the second, and the first minus the second. All right? So try number 30. It should be the same thing here, right? M squared n squared. So this is no different from number 29, right? So this should be m n in parentheses squared minus 64 is 8 squared. So as you can see, this is a difference of squares question, right? So we have the, oh gosh. Here we go. Sorry about that. So this is what? This is our first mn plus 8 times mn minus 8. Okay? Alright, last 4 problems I want you, actually the next 2, just the next 2, I want you to try them on your own and make sure you don't mix up the terms. The first one is the number minus the variables, okay? So 31 and 32, give them a try, and we'll go over 33 and 34 together. Forget. Okay, let's see. Number 31. We know that 25 is 5 squared minus a squared b squared is just ab squared, right? So that gives us the two factors of 5 plus ab times 5 minus ab. All right, number 32. So we got 49, which is 7 squared minus w squared z squared. So that's wz in parentheses squared. Difference of squares, so this is 7 plus wz times 7 minus wz. Not bad, right? Alright, so number 33, let's do together. R to the 4th, we went over a problem earlier, just kind of like this, right? So we can divide it by 2. That's r squared, right? and then that's squared. Minus 4s squared, we know that's just 2s, parentheses squared. So we have r squared plus 2s times r squared minus 2s. And we are finished. That's it. Look at number 34. Same idea here, right? So the first one is just p squared minus 9q to the 4th. So that's 3q squared, right? You divide the 4 by 2, and you get 2. So this is the difference of squares. This is p plus 3q squared times p minus 3q squared. And that's it. Okay? Does anyone have any questions about what we learned today? I know this one right here, right? The perfect square trinomials is probably the most difficult. Please practice this thoroughly, okay? This one is, I mean, because it has 3 terms, it might be a little more tricky, but don't forget, this is just 2 times, if you forget the rule, right? It's 2 times the first times the second has to equal the middle term, right? Yeah, so I'm going to give you homework problems on Blackboard. Give them a try, and then we'll go over all the homework on Wednesday. Okay? Alright, I'm going to have to video edit a lot today because I made so many separate videos, so it might take a while to post on YouTube. It might actually not even be up until tomorrow, so yeah, bear with me, okay? Alright, everyone have a great day. I will see you all on Wednesday.